Okay, so this is section 1.3. So we're going to start with translating expressions into algebraic expressions. Here we have 3 times the difference means subtraction, of a number and 8. So it's 3 times the difference of a number and 8. We keep that order, so it's x minus 8. All right, next we're going to translate this into a verbal expression. So here we have a number p which has been cubed. So we say a number. You can say a number p, or you could just say a number p cubed added to, right, plus added to 4 times, and here's the important part, the same number. Okay, and that's it. So here we have an equation. So we have 2c, so we can just say twice a number equals the number, right? When you say the number, it means that same number. The number squared minus 4. And yeah, there are more ways of saying this. You know, you could say, 4. You can say, the difference between the number squared and 4 and so on. Many different ways. Okay, so let's solve some equations. First off, we're going to add 14.29 to both sides. So we're going to get that x is equal to 39.29. Next, we're going to multiply both sides of this by 3 over 2. So when this cancels, we get a 9, we get a 1, y equals negative 27. Okay, moving along. Here we're going to do some more work. So this is negative 10x plus, distribute the 3, so we get 7.5x minus 6 is equal to 6. So here I get negative 2.5x is equal to 12. Now, the negative 2.5x, you have to divide, right? But I don't want to divide 12 by 2.5, especially if I don't have a calculator. So instead, I write the 2.5 as a 5 over 2. So now I can just multiply both sides by negative 2 over 5. And then I get x is equal to negative 24 over 5. And that's a perfectly reasonable answer. It's simplified, so we're good to go. Okay, here we're going to distribute the 3 over 2. So we're going to get 45 over 2d plus 3 times 20 is 60 divided by 2, that's 30. Distribute the negative 1 over 6 minus 3d plus 2 equals to 38. Okay. So now 45 over 2d minus 3d. 3d is 6 over 2. So 45 over 2 minus 6 over 2, that will be 39 over 2. D is equal to, so here I have 30 and 32. I subtract from the 38, so I just have a 6. And now I'm going to multiply both sides here by 2 over 39. 2 over 39. So D is equal to, when you distribute and simplify, you get 4 over 13. Okay, moving along. Here we have the equation of a trapezoid, a formula for the area of a trapezoid. We want to solve for B1. Okay, so here's B1 right there. First, what we have to do is we have to get rid of that 1/2 h, which is h over 2. So I multiply by 2 over h. 2 over h. So I get 2a over h is equal to b1 plus b2. And in order to solve for b1, I need to subtract b2. So I get 2a over h minus b2 is equal to b1. Okay, next. Here, we need to solve this for y. So, let's see what we can do. I'm going to subtract 4x. Now I want to bring all the y's to the left-hand side. So here I'm going to add 3y. Add 3y. So let's see what we have now. We have negative 3y plus 6 is equal to negative 3x plus 2. Okay, subtracting a 6, I get negative 3y is equal to negative 3x minus 4. Now we're going to divide everything by negative 3. So I'm going to get that y is equal to, oh, I'm sorry, I knew that I messed up here. I'm sorry, I read that as a 9. I read this as a 9, but it's a 4. I'm so sorry. This should have been a 2x. Oh, that's okay. So I need to write more legibly. See? Okay. So now we get 2x minus 4 over negative 3. Okay. All right. So here we want to solve for x. So we're first going to multiply both sides by x minus 4. So we're going to get y x minus 4 is equal to 2. And now I can divide by y. X minus 4 is equal to 2 over y. X is 2 over y plus 4. All right, let's go on to section 4. We're going to talk about absolute values here. So an absolute value of a number is basically the distance from 0 of that number on a number line, right? So for example, if I have a number line here, and if I tell you what is the absolute value of 4, what I'm asking you is how many units away from 0 is the number 4? And that's just 4. Similarly, if I ask you what is the absolute value of negative 4, again, I'm asking you how many units away from 0 is negative 4, and that's also 4, right? So that's why the absolute value of positive 4 is 4, the absolute value of negative 4 is 4, because they're both 4 units away from 0. Similarly, if I were to ask you a question like this, what number can you think of the absolute value of which is equal to 2? In other words, what number is 2 units away from 0? Well, if this is 0, 2 units away from 0 can either be positive 2 or negative 2. So that's why x is positive 2 or x is negative 2. Okay? So that's all an absolute value is. So always think of it that way, right? Whatever is inside the absolute value, when you have an absolute value equation, you're asking the stuff inside the absolute value, right, has to be this many units away from the origin, from 0. So for example, take a look at this one. Look at this here, okay? What we're trying to say here is that this number x minus 5 is 3 units away from the origin, right? So that number can either be at negative 3 or it could be at positive 3, right? So if x minus 5 is at negative 3 or x minus 5 is at 3, then x will be at 2 or at 8, okay? So that's what central value and range are. X minus c, so this number is the central value and the range is how far away it is from 0. It's easiest when we just solve one and then we'll take a look at what we're looking at, okay? So take a look at this one. X plus 3 is equal to negative 6. So we say x plus 3 is negative 6. X plus 3 is positive 6. So here x is equal to negative 9. X is equal to positive 3. Okay, so where is negative 9? Right there. Where is positive 3? 1, 2, 3. Right there. What number is smack in the middle of those two purple dots? Well, that is negative 3. Okay, now can we find negative 3 in our equation? Of course we can. If you take the x plus 3 here, set it equal to 0 and solve, you get x equals negative 3. That's the central value, negative 3. Now, how far is negative 3 from each of the points? 6 units, and that's that number right there. Okay? All right, so let's take a look at this one. Before we do anything here, we have to isolate the absolute value. So we're going to add 1 to both sides. Divide by 2. So now I say 2x minus 7 is equal to negative 2. 2x minus 7 is positive 2. So here, 2x is equal to 5. X is equal to 5 over 2. 2x is equal to 9. X is equal to 9 over 2, right? So where is 5 over 2? 2.5. Where is 9 over 2? 4.5. And what's that central number? Here, 3 over 2. 7 over 2. Okay, now. So because the absolute value is the distance away from 0, okay, just like we saw here at the very, very top, if the absolute value of something is equal to a positive number, we get two solutions. If the absolute value of something is equal to 0, now you're looking at, okay, how many units away from 0 is x? Well, 0. So we get one solution. And if absolute value is equal to a negative number, then we have no solution, because how can the distance from 0 be a negative number? Okay. All right, so for this example here, when I divide by negative 2, I get the absolute value of 3a is equal to negative 3, and that just does not work. Okay, so sometimes we actually get extraneous solutions. These are solutions that, will come out when you do the math, but they don't work out in the equation. So let's take a look at this one. We're going to check for extraneous solutions when you have a variable inside the absolute value and outside of the absolute value. So we do this in the same way. The stuff inside the absolute value, 3x minus 1, is equal to the negative of x minus 7, and then 3x minus 1 is equal to the positive of x minus 7. So let's go ahead and solve this. Okay, so here we have 4x is equal to 8, x is equal to 2. Next, here we have 2x is equal to negative 6, x is equal to negative 3. So here I have potentially two answers, but I want to know if this works in the original equation. This is the original equation, so now we got to check. Okay. We take x equals 2 and we're going to plug it into each of the x's here. So let's see. 3 times 2 minus 1. Does this equal to 2 minus 7? Well, that's, what is that? 6 minus 1. Does that equal to 2 minus 7? Well, 2 minus 7 gives you a negative number. How can an absolute value equal a negative number? So no, that does not work. Well, let's check the other one. Does this equal to negative 3 minus 7? Again, how can you get an absolute value equal to a negative number? So no. So this one has no solution. Okay. All right, let's take a look at this one. Since the absolute value is alone, we can start off and say 2x plus 5 is equal to negative of this. 2x plus 5 is equal to the positive of this. Okay, so 2x plus 5 is equal to negative 2.5x plus 8. And here we're going to get 4.5x is equal to 3. All right, so the 4.5x, again, I'm going to write it as 9 over 2. X is equal to 3. Multiply both sides by 2 over 9. So I get that x is equal to 2/3. Okay, here, let's subtract. I'm going to get negative 0.5x is equal to negative 13. Well, negative 0.5x is negative 1/2. And so x is equal to positive 26. Okay, well, let me not circle it because we still have to check. So let's go ahead and check. Okay, does the 2/3 work? 2 times 2/3 plus 5 in the absolute value. Is this equal to 2.5 times 2/3 minus 8? You know, I'm actually going to keep writing the 2.5 as 5 over 2. I just like fractions so much better. So here, right, these go away. You have 5/3 minus 8. That's a negative number. That can't equal to an absolute value, so that doesn't work. Does the 26 work? Um, 2.5 times 26 minus 8. This does work. So the only answer then is that 26. Okay. Let's do another one. 2x is equal to negative x minus 3. I just distributed it in one shot. 2x is equal to x plus 3. 3x is negative 3. X is negative 1. What about here? X is positive 3. Okay, so I believe both of these things are going to work. So both are solutions. Okay, but you have to check on the quiz. If you have two solutions like this and, you know, let's say you checked mentally and on the answer space, you wrote negative 1 and 3, but you haven't shown me this part about the checking, I have to have points off. I have to take points off because you actually have to tell me that you know that you would have gotten an extraneous solution and that, you know, that's a possibility and you have to go and check. Okay, next one. Before I can do anything here, first I need to isolate the absolute value. So add x to both sides. Divide everything by 2. Okay, so now I can say x, oh, sorry, this is a plus 1. X plus 1 is equal to negative 2, x minus 2. X plus 1 is equal to 2x minus 2. So here, x plus 1 is negative 2x plus 2. When you solve, you get that x is equal to 1/3. Here, you get that x is equal to 3. And so again, we're going to go and we're going to check. To check, you have to plug it into any of the steps where the absolute value is still there. So this is okay, this is okay, this is okay. Now I would probably check in here because that's the most straightforward and it's the simplest, right? So we would do 1 over 3 plus 1. Is this equal to 2 times 1 over 3 minus 2? Clearly it's not, so that doesn't work. And then of course you have to check the x equals 3 as well. It does work, so this is the only answer. All right, so that's sections 3 and 4. Have a good evening, everyone.